We made it the last round of talks. I am happy for you guys to all be here because I know there's a bunch of other really good talks happening at the same time. So I am going to talk about signals. Just a quick show of hands, who of you are JavaScript developers? Okay, because I know that's kind of like a rare thing here at the conference. So again, I appreciate coming to this talk. I'm going to show a lot of JavaScript here. The fundamental principles are applicable to any other language. But it's going to be very JavaScript heavy in the sense of going through the idea of what signals are and why they're becoming so popular, especially in JavaScript frameworks. What all the fuss is about, what problems they're trying to solve, and what some of the alternatives might be. And to understand that, we need to understand what signals are in the first place. So if I get my clicker to work, which I don't, so I'm just going to do this. No, that's not what I wanted to do. Great. Okay. To understand what signals are, to understand what problem signals are trying to solve, let's look at what signals actually are. So in JavaScript, the concept of signal, the idea of signals is the concept of reactive variables. So by default, variables are not reactive in JavaScript. So if I have this example of like I have a counter, and then I have derived values of that. So I have an is even, so if the counter is even, I want to set that to true. If it's odd, I want to set that to false, and then I have a parity variable that's just a string, even or odd. Whenever I change counter, the derived values don't automatically recalculate. So this is just pure JavaScript. I have to recalculate them manually, and especially if I have like large and complex state in my application, this can get very heavy very quickly. Of like, I have to constantly remember that I have to recalculate things when they're derived from other values. So that is pretty tedious. So the idea of reactive variables is a concept of telling the compiler, hey, this variable relies on another variable. Whenever that dependency changes, recalculate me. So this is pseudocode, so this has nothing to do with signals yet. But let's imagine we had like an assignment operator that tells the compiler exactly that. So in this case, we have like the dollar equal. Again, this is pseudocode. This is not actual JavaScript. But we can pretend that this tells the compiler, hey, this variable actually relies on another variable. So in this case, we could have counter is just still a normal variable, but then is even and parity we define as reactive variables. And we want the compiler to automatically recalculate them whenever their dependencies change. So if I set the counter to 6, it would automatically do all the recalculations under the hood for free. That's the idea of signals. So it's the idea of fine-grained control over your state and derived values. Why does this matter? Why do we want that? With a few of you being JavaScript developers, mostly what we do as front-end developers is handling state and translating the state into UI, and then handling actions that change the state, and then changing the UI based on the state. That might sound boring, but that's mostly what we do. And when I started developing, the concept was Model View Controller, MVC, which was pretty popular. So you have like your state, your view, and your UI. And the idea is that your view is always a pure function of your model. So in more modern terms, like your UI should be the result of a pure function of your state. And the pure bit is really important because basically what we want is, for any given state, we want to have like a predictable UI. If I feed the same state in, I want the same UI as an output. So this is a pure function principle. Signals, how did we get from here to signals? Because signals, by definition, sound pretty side effecty, right? Because it's like, okay, I change a variable and then other variables change based on that. So why would we want that? If the principle is like, no, we want a pure function and we want like clear, predictable state. To understand that, we kind of have to take a look at the history of web rendering and how we even got to where we are today. And for that, we have to start at the very beginning. So if we go back all the way to just plain HTML and some kind of server-side language, so that could be PHP, that could be whatever you want to run on the server, that doesn't really matter. But you usually have this idea of like a templating that you have here, and then basically a template just describes what you render in your HTML. And in there you can have some state. So in this case, our state actually comes from the URL. So we have a query parameter counter. We get that in our PHP, and then we attach that to the template. And this is great because it's exactly what we just saw, right? We have a view, we have a pure function, in this case a template, it runs, and it's very predictable, and for the same state you will always get the same HTML. And this is what we call the pull approach. So in the sense of like we're pulling the state from the server, or like every time the state changes, we pull the new HTML from the server and we re-render the whole thing. So in this case, if I click on one of the links, the counter in the URL would change. That triggers another server request. The server pulls the whole HTML again and gives me a fresh HTML with the new state. So like I already mentioned, like this is very good for predictability. You have a very clear flow of the state goes in, it produces an HTML, you know exactly where that HTML came from, etc. Whenever the state changes, again, it's very predictable because it's top-down, essentially. Now, the predictability and the templating and like the DX is really good. The only downside really, or like the big downside here might be obvious, it's performance. So if your app gets really big, every time any state changes, if the whole page has to re-render, that's obviously really expensive. Especially with modern apps where you have like a lot of state going on. So very quickly, especially like with the introduction of JavaScript and jQuery, we started experimenting with, okay, what if we bypass some of that? What if we try to be a little bit more selective? So with jQuery and the introduction of Ajax, we were able to not re-render the whole page, but selectively just ask the server for the part of the page that we know will change. So in this case, we have still the counter example. If we increase the button or decrease, instead of doing the whole re-render, we actually, via JavaScript, go to the server, ask for specific content, and only replace that content. That's still a pull approach. So every time the state changes, we still go to the server, but I would call it an improved pull approach because we're not asking for the whole HTML, and we're in control of it because it's all happening client-side, so we can show like loading state or whatever. So we're basically still pulling new HTML based on the state from the server, but very selectively. Then we kind of, as JavaScript developers, we always kind of like go a little bit too far. And we went like, okay, what if everything was client-side? Like there's no server at all anymore, so we have the HTML, it gets served, and then it's just a JavaScript that deals with it. And instead of asking the server for new HTML when something happens, on the action, we actually just mutate the DOM directly. So in this case, when the user clicks the buttons, we actually go in directly and get the span and write to the inner HTML of the span. This is great for performance because now we don't have the round trip at all anymore, but it completely flips the mental model. So we're now not pulling from the server anymore, we're actually pushing into the DOM. So this is a fundamental shift from the pull approach to now the push approach. We get the initial HTML still from the server as an index HTML file, then we have DOM, we have actions in that DOM, but then we just mutate the DOM directly. Again, it fixes the performance issues, but it completely removes all the benefits that we had from the pull approach. So it's less predictable, it's much more likely that you accidentally introduce inconsistencies with your state, because again, you don't have like a state flowing down through a pure function. You're manually updating your UI in various places. So if you have like the famous Facebook example, when you have like notifications icon at the top and like your list of messages, they can be out of sync if you manually start pushing your states. So that's the big downside. The other big downside with jQuery, I might be showing my age here. Like jQuery, I'm a huge fan of jQuery because I think it shaped the way we're writing JavaScript, JavaScript as a language, how it evolved. It's just unfortunate that it was a little bit ahead of its time. So when jQuery was really popular, NPM wasn't really a thing, and there weren't many libraries out there that would help you build large-scale applications. So a lot of us would write what jQuery is now known for like spaghetti code. Like we would all reinvent the wheel, write our own solutions. And that's mainly what it's remembered for, which is unfortunate. But it also meant, like, at the time, this was great of like, okay, we're updating the DOM, this is great for performance, but the developer experience was abysmal, essentially. Introducing the era where we actually do go into frameworks and libraries that help us with application development. So I'm mentioning Knockout here. You might have used something else. This is mostly from my personal experience. That was one of the first frameworks that I started using. But I'm also mentioning it for a few other reasons. Knockout was one of the first libraries, together with Backbone, to introduce the concept of what we would now call signals. So they called it observables. And basically the idea is there's several layers to it. So Knockout introduced the idea of an application framework. So there's 3 layers to that. We have the templating, where we describe the HTML that we want to render. Then we have a way to describe our state or manage our state. And then there's the layer in between, which we call data binding here, which allows us to access our state within our template. Like, that's the important part. And fundamentally, this is still a push approach. So underneath the hood, what Knockout is doing is still manually updating the DOM whenever state changes. But through this templating and data binding layer, we're pretending that it's a top-down pure function approach. This gives you the idea of full control over, what's going to render at any given time based on your state. So this is trying to get the best of both worlds. You have the performance of the push approach, but the developer experience of the pull approach. And the way Knockout does it is by introducing these observables. So an observable is basically the idea of a reactive variable. So I'm saying counter is a variable that I know will change, or I want to be able to change. And then I have computed, which is derived values. So whenever anything within that function that computes that computed value changes, I want to recalculate this computed value. So again, the example is the same. We have a counter, and the parity will change based on the counter. And again, this is trying to get the best of both worlds. So from the developer experience, we still have that very clear, descriptive, and very deterministic way to describe the UI. And that caught on. So like a lot of other frameworks in the JavaScript ecosystem have been doing the same thing ever since. It's just the terminology of like what they call it and the implementation detail, but fundamentally, all of them are doing very similar things. So Vue, in the very beginning, had the idea of data and computed. And even in the newer, like Vue 3, you have similar terminologies where, again, you have your state and you have your derived state, and you have your templating language where you can access your state within your HTML. Svelte, this might not look like it, but it also was doing the same thing. So Svelte is actually hiding it underneath the hood of like, or they used to hide it in the compiler. So the compiler at build time would actually turn these into signals. So Svelte would know that this needs to recalculate whenever counter changes. They realized that's a little bit too much magic. So in 2019, they introduced runes, which again just makes it more explicit what's actually happening. So you define your state, and you have your derived state explicitly through these rune dollar functions. But the idea is exactly the same. So I can just mutate these variables, and my derived state will automatically recalculate. And through the templating, my HTML knows exactly what needs to update whenever these signals change. Solid is probably the most famous for signals because they kind of like coined the term signals. At least I think so. And again, it's doing exactly the same thing. So we have like a create signal function that gives us a signal for our state and a state setter, and then we have derived state that just automatically recalculates. And this starts looking much more like if you're familiar with React or any other JSX-based frameworks, this might look familiar. So instead of having like a separate HTML template, we're actually returning our HTML through JSX in our JavaScript function. The one thing that I would say, like, this could go on and on. Like other frameworks started adopting more and more. So like Angular, I think last year, also switched over to signals as their core architecture. And more frameworks are doing that. This seems to be like a common theme. Over time, this obviously evolved. Like, yes, it's still the core principle of like we went from pull from the old days in HTML to push and now like specifically updating DOM. But the implementation kind of evolved to more efficient strategies. So what Solid actually does is a push and pull. I will explain that a little bit later, but the key thing to notice here is there's improvements that we've made over time to the algorithm, how to actually do the push approach efficiently. Let's talk about the elephant in the room. So all of these frameworks seem to go in the same direction. Everyone moves to signals. What about React? React famously doesn't use signals, at least in its core architecture. And the reason for that is pretty simple. It's fundamentally React uses the pull approach. They embrace the pull approach in the sense of ideally, every time state changes, the whole app re-renders. And what they try to do is just make that app re-render as efficient as possible. And React does that in multiple ways. So for one, the component architecture in itself. So having your application broken down in components and your state being specific to components means whenever state changes, only the subtree where that state changed needs to re-render, not your whole application. So that's a big win to start with. But then it does a few things on top of that. React introduced like the concept of virtual DOM, meaning it does a bunch of computation to see what will actually change based on the state changes, and then only apply those changes to the actual DOM, trying to save computation of like we're not mutating the DOM where it's not needed. And it does a bunch of memoization. So if you're using React, you're probably aware of like your use memos and like use callbacks and all of that flying around everywhere. That is exactly for that reason. It's like trying to memorize as much as possible, so when state changes, but it doesn't actually change what you're rendering, then React can skip that and just use the memoized state. Again, this is all just to get the developer experience benefits that we described in the beginning of like, okay, the pull approach is very predictable, it's easy to debug, it's easy to reason about, it's very hard to actually mess up your application to have inconsistent state if you have that pull approach that just, again, the pure function takes your state and gives you a UI. So this is fundamentally why React is not moving to signals, and they're doubling down on that. So the whole memoization piece, this is, by the way, this is a talk that I highly recommend watching. This is ages ago, I don't remember when exactly it was, but like this is basically the Facebook team introducing React when they first came out with it, and they describe exactly that motivation of like the Facebook app was just so buggy in its state management, where like you change state here and like not all of the app actually updates, etc. So React came out of that, where they really wanted a more predictable, easier to reason about declarative model of rendering. Flux, eventually Redux, as a state management, again, the same concept of like your state flows down. You have a very predictable model of state to UI, essentially. And with the, yes, no.
The signal is handling, as you said, push signal the UI that there is a change, show a progress or something, or even data is coming to the front end in steps. So that's for that purpose as well. So how React kind of address things?
I'm not sure I understand the question. So,
I said signal is for suitable for web backend has many steps, and once again, each step, end of each steps, one notify UI there is a change. If you want pull and see what's the change, right? That's another usage of signal.
yeah.
So what you said React is pull based.
Yeah, it's not.
How handle that?
Yeah, so it's pull-based in the sense that whenever the state changes, it will re-render the whole thing. Like it will basically pull the new HTML, not from the server because we're not on the server essentially anymore. Like we're single page. Like in a,
Angular is the same, but signal, integrating a signal, so you have this option from back end notifying UI that there is a change, the render. Right?
Yeah.
No matter where you go. So I want to know how React handles this.
in the same way. So like you will have some state in your React application somewhere, usually with backend data, like somewhere at the top. And whenever that state changes, like if you fetch the data, you will update that state. And then React just fundamentally, whenever state changes, it will re-render.
So the handles there is something not signal or something else. How
No, there's no
there is no
signals in there. So this is what I'm getting at is, by the way, definitely feel free to ask questions. Don't feel like you can't interrupt me. Small enough group here. But yeah, again, React tries to make those re-renders just very efficient. So through a lot of memoization, they try to then, technically in the virtual DOM, everything re-renders, but the actual DOM only updates what really needs to change. And they're doubling down on that. So like the new React compiler basically does what Svelte did originally and then realized wasn't a good idea, is it's hiding a lot of that memoization away. So if you're using the new React compiler, you don't have to use memo and use callback anymore because the React compiler will do that underneath the hood. So any functions or any state that you actually have, any derived state, it will try to memorize based on smart rules. And again, the whole goal is it will still fundamentally re-render whenever the state changes, but that re-render ideally gets cheaper and cheaper. Which again, the whole promise here is that that just makes it basically impossible for you to have inconsistent state across your application. And it makes the framework itself simpler to reason about. And it's not that they haven't considered signals. So it's also worth mentioning that the React team has done experiments. This is from the ReactConf last year, where they actually presented some of those. It's called, like, this is experimental React Fear. I don't know if that's the final name, but like that's what they experimented with. They tried React as it is, as a performance metric, then React with signals, which definitely made it faster. So again, they also acknowledged that just signals can help with performance. But the idea is if React in itself can actually do a lot of that memoization and can make the re-renders more efficient, React plus the new compiler will be even faster than React with signals. React Fear is kind of like what they're working on for performance improvements, and they're working on, okay, external stores. How can we actually make state management, especially when you come like data from an API, how can we make that better as an architecture and more efficient? So this is mostly to show like they're thinking about that, they have experimented with all of that, and there's cool stuff coming, but fundamentally I don't see React changing anytime soon from their current pull approach to a signal-based approach. All of that is to say, I don't think there's a right or wrong here. I hope you can kind of see of like, okay, there's just two fundamentally different approaches to the problem. If it wasn't for the performance penalty, I think everyone would do the pull approach, again, just because it's much more predictable. But there is a performance penalty, so it's really just a question, can we make the framework so efficient that it's not an issue, which is what React tries to do, or are we going the other way where the framework does a lot more heavy lifting, but signals allow us to make the apps just a lot faster. So that's really where we're at the moment. Again, I hope that kind of gave you a view what signals are, why, like what problem they're trying to solve, and how we got into this situation where a lot of frameworks start adopting them. React, that's like the famous big one, hasn't and won't. But how do signals actually work? Like, how does that magic happen of like, okay, I'm changing the state, so all of the derived state automatically changes underneath the hood? For that, let's actually implement it ourselves. A very, like, disclaimer, this is a dumbed-down version. I'm mostly just trying to get the concept across of like what the idea of a signal and a signal lifecycle is. So here we have a state, like a button. Oh, you can see that well enough. And we have the parity again. So whenever I click the button, I want to increase the counter, and I want to change the parity based on the current counter. So right now it doesn't do anything because we haven't done anything yet. But if I would write that in plain JavaScript, I would probably do something like this. So I can select my button, and I have an on-click handler. And then I get the current state. So I can just read the state from this value 1 span. And then I want to increase the state. So I have a new value 1. And based on that, I can calculate my new parity. So new value 1. Go. And then I'm just doing, again, the traditional push approach of, not traditional, the push approach of, I'm just writing straight to the DOM. So updating value 1 directly, and updating parity directly. And hopefully, yeah. So that's fairly simple, right? So I'm reading the current state from the element, I'm increasing the state, I'm calculating the derived value, which I have to do every time the state changes, and then I'm updating the DOM as an effect of the state having changed. Now, the project manager, yes, this button has a project manager, comes in and says, like, we want a second button. And now we have 2 counters, and we don't only want the parity, we also want the sum of the 2 counters, and then the parity is basically off the sum, which is fair enough. Now we just have a second value, so we can easily just copy that, get the from value 2, to rename that as well, and button 2. We're still increasing the counter 1 on clicking that, but now we have a new sum, so that's another derived value, and that's new value 1 plus value 2. And the new parity is of the new sum. And then here we also update the sum. So that still works, but now we have to implement the second button as well. And it's slightly different because we're not increasing value 1, we're increasing value 2 now, so it's probably easier to just copy and paste. And then we're still reading both values, but instead now here value 2 and value 1 plus new value 2. And the rest is pretty much the same. So this is still fair enough, I guess. So this works. But you can already see, like, it's starting to get out of hand pretty quickly. We're starting to have a lot of duplicated logic, and we're starting to mix a lot of concerns of, okay, where am I actually declaring my state? Where am I declaring the actions that change the state? Where I'm declaring the effects that should happen whenever the state changes. It's a lot of manual work, and if we add another button, say we want a third button that's increasing both counters, again, it's slightly different, so we can't really use the same callback, so we would write and copy paste another one, have a button both here, new value 1, so we increase both values and then sum them up. So again, I hope you get the idea of like this gets out of hand pretty quickly. But you can see, like, it technically works. Like, there's nothing wrong with the solution. It's just very hard to manage. So if we imagine instead we had like a nice library that we can actually import, and we can say, okay, cool, give me a signal, give me some computed value that I can use to derive state, and give me some effects. And we just call it signal. So if we had that instead, we could have a very clear distinction between, okay, let's define our state. We have value 1, just like the value of the first counter. We initially set it to 0. We have value 2. And then we have our derived values. So for some, we can get and parity. So this way we have like at least very clear and concise, this is our state that we have. And then we want to have the effects. So what should happen whenever the state changes? Which again can be very concise because we can be very granular. Whenever value 1 changes, we actually want to update the counter, right? So window value 1 in our text. And the same for value 2, sum and parity. So again, we're very explicitly now just concerned with, okay, whenever the state changes, what are the actual DOM updates that we want to do? And finally, we still want to have our actions. So we still have the click handlers here. But all these really do is update the signal. So instead of having all of this mixed up logic, we can just go setting the new state of the signal. So we increase it by 1. For button 2, we do exactly the same with value 2. And with button both, we want to increase both counters. All right. So I hope like this hopefully shows that just by splitting it up into like, cool, we have signals that help us define our state with signals and computed for derived state. And then we have effects that describe what actually should happen when the signals change. And then we have our actions, and we have it nicely split now. It's much easier to read, it's less code, it's easier to reason about. So from a developer experience, this is nice. But we obviously haven't implemented any of that yet. So how do we do that? Let's actually go into the signal.js and do that. So this signal function, we give it an initial value. And really what the signal does is two things. It keeps track of its current state. So let's have a value in here that we set to the initial value. And then we return what we saw here. I basically gave it a getter and we have a setter. So like we want to be able to get the current value and to set a new value. So the get function really just for now just returns the current value, and the set function updates the value. Cool. Then we have the computed, which again is for derived state. And what we're passing into the computer is really just the function that calculates the derived state. So we're passing in a function, and for now, we're just returning the getter. Like, computed only has a getter because by definition, you're not setting a computed value, you're describing how the computed value is calculated. And whenever we run the getter, we just execute the function. And then we have the effect, which also just takes a function of this should run whenever any of the signals within it change. So for now, we literally just execute that. And this is the most basic setup. Again, I'm skipping a lot of like complexities when it comes to signals. I'm going to explain that later. But the fundamental idea is, okay, you have a signal that keeps track of your state, and then something needs to happen, right? Because right now it still doesn't do anything. The magic part is when the signal tells everyone else that it changed. So essentially, it's good to think of signals as a form of event system where whenever the signal changes, it sends an event to all its all the functions that use the signal to tell those functions, hey, my value changed. You might need to recalculate things. And to do that, we basically just need to keep track of like who's actually using our signal. So for that, we need two things. We need to know which effect is currently running. So we can store that in a variable, and whenever we're running an effect, we're actually just storing that function and then resetting it to null. And once we know that, we can say like, okay, whenever somebody is reading from our signal, we basically keep them as what I would call subscribers. So again, this is like the event-based idea. Whenever somebody reads from our signal, we add them to our subscribers array. And then we're basically just keeping track of like, okay, where is the signal being used? And then whenever our value actually changes, we loop over the subscribers and basically have them recalculate their things or rerun the effects or whatever. So fundamentally, all we're saying is, okay, we have some form of effects. Whenever these effects run, we want to keep track of what signals they are using. Whenever these signals change, we let all of these subscribers know that the signal changed. And with these 30 lines of JavaScript, we basically implemented a very basic form of signal, which is not. Yes, thank you. Where is it? Yeah. Cool. Live coding. But you can see, like, basically the fundamental principles are actually a lot less complex than you might think. Again, we have the fundamental, we're keeping track of the value, we're keeping track of our subscribers, and the magic piece here is really the subscription piece and the automatic subscription. When I'm using an effect, it will automatically subscribe to any gets that I'm running here. There are obviously still challenges. So I mentioned it a couple of times, like I skipped over a lot of complexities here. What are the main challenges with signals? One thing, basically with signals, you have to deal with what I tried to describe before. We're not doing the pull approach, so we're not having this predictable pure function model, which means we can have inconsistencies in the state. So with signals, the order of recalculation matters. So in this example, if I have a counter and I have an increased computed value, by definition, that increased computed value is always the counter plus 1. So it should always be greater than the counter. So if I then have like another computed value that just checks that, if the increased value is greater than the counter, that should always be true. If I'm not doing the recalculation in the right order, I can get into weird states where is greater is recalculated first before increased is recalculated. So if I increase the counter, is greater is now comparing to the old counter, to the old is increased. So it actually gives false. Then the increased is actually getting increased. So like the order of recalculation really matters. So signal implementations usually just use topological trees to know in which order they need to recalculate the values based on their dependencies. So that's just important to keep in mind. Other glitches that you can have is especially around batching. So if you have multiple signals and you change the signals like we have like increase both and we increase both counters. By default, like the implementation that we just did, it would trigger two effects. So we would increase counter 1, which would cause some to recalculate with the new counter 1, but still the old counter 2, and then it would increase counter 2. So you have an intermediate state essentially where in your UI, if it's not fast enough, you could actually see like a glitch of it goes to 1 first and then to 2. So again, modern frameworks work around that, and they just batch any signal updates within the same render cycle. And then there's smart optimizations that you can do, especially around figuring out which values actually do need to recalculate. So this is kind of going towards what Solid especially started doing, optimizing the way they do the signals with a pull and then push approach. There's two things that you can do. For one, modern signal implementation keep track of what they call the dirty state. Essentially, whenever a signal changes, it keeps track of, in this case, so we have counter, and then we have two derived values, is, even, and parity. When we change counter, we mark it as dirty. And then for every derived value, we see if any of their dependencies are dirty, we know we need to recalculate because the derived value might have changed. So in this case, is even, should be even, not event, is even is relying on counter, which is dirty. So this is this needs to recalculate. But after recalculation, we see it's still coming to the same value. It's still false. So we change the counter from 3 to 7, but like is even still is false, which means compared to the previous value, we know this hasn't changed. So any derived values that rely on is even don't need to recalculate because we know it hasn't changed. So long story short, this helps with just skipping a lot of computation where it's not needed. The other thing that modern frameworks do is not recalculating immediately, but only recalculating when the signal is actually being used or being read. So this is the, yes, we're actually pushing the state change, but we're not immediately pulling it for the UI because like the component that actually uses the signal might have been already gone. It's not in the UI anymore. So it's only on active read where the recalculations actually happen. All right. All of that is just to build up to why I'm actually excited about signals, which is the TC39 proposal that's currently in the air. And it kind of leads to the whole discussion, what people call like the carcinization of the web. Don't know if people know what carcinization is. Essentially coming from biology, where there's a thing where crustaceans independently all evolve into crab-like creatures with like the same features. And essentially, people start joking that our crabs are the ultimate form of life because everything becomes a crab eventually. It's not that extreme, but like the idea is if the pressure is putting you into a certain situation where the solution independently will always evolve into the same direction. And we're seeing that on the front end in various things. And one of the things is with signals. Like we've seen in the beginning, a lot of frameworks independently started moving more and more towards this signal-like structure. but they're all doing their own implementation of it. So the whole idea of the TC39 proposal is to actually bring signals into the JavaScript core. So it would become a fundamental thing within the JavaScript language, essentially. And the obvious idea here is to not have frameworks reinvent the wheel over and over. So we're taking some of that responsibility off the frameworks into the language, have one implementation that everyone can use, and then the frameworks can actually focus on doing what they need to do to actually make the framework work. This is the current proposal. This is still in stage 1, so this is likely still going to change, but you can see that this is very similar to what we did in our very simplified implementation. So we have like a signal state where we can define the signal. We have a signal computed where we can define derived state. And then it will define like an API for the effects, but you will probably never use that directly. Like your framework will always abstract that away. So if you're using Angular or if you're using Vue, it will take the effects and like do the DOM updates, etc. for you. But technically, you still have that capability of like doing effects based on signals changing. All of that is to say, if I triggered any interest in any of that, definitely check out the repo where the proposal is currently hosted. They have a bunch of examples. They have a lot of description of like, again, what is the core reasoning? What are they trying to achieve? There's polyfills, so you can already start using this and start experimenting with it. They are trying to bring all the frameworks on board to start adopting it to see how it performs against their current implementations. And there's a bunch of other resources that I highly recommend. So again, if any of that is interesting to you, reactivity in general, signals, how they're implemented, how fine-grained reactivity works, these are really, really good resources that I recommend. And I think we're pretty early, but like I think we're also like the end of the day. Everyone is getting pretty tired. This is a link to the slides. You can use the QR code. This is my socials. I'm not very active on them, but there you go. And yeah, thank you. We have plenty of time for questions if anyone has questions.
I just want to explain that one. I mixed that signal or any knowledge of the signal. For example, this one is just UI kind of state changes. But
Yeah.
that one was back one. So apology for that.
So you were
Yeah,
You
signal
mixed
or
up
is
the signal
something.
R.
yeah, gotcha. Yeah, gotcha.
I mixed that concept with this one. Sorry about that.
No, that's fair. That makes sense. Then I understand your question now.
So, what is it for use?
Oh, that's so we are currently using Angular. So Angular already got signal implementation in the latest.
Yeah.
We are like, I don't know, version 20 or 21, whatever. So is it safer to keep using it? So I mean,
Yes,
considering all
absolutely.
the changes, proposals coming up.
Absolutely. So the only thing that I hope with the proposal is that frameworks will remove their custom implementation of how signals work. And eventually, like, that's just becoming part of the core language. And what that means is, and we've seen that before with Node.js, where like a lot of language standards, like everything became standardized, and then vendors could actually optimize. So like browsers can start optimizing for that specific language implementation. So once we have like signals in the language, Chrome, etc., can start making that very efficient. Where right now it's just so scattered that every framework has its own little like quirks and like the way they do the topological trees and how they try to be more efficient, etc. So absolutely, it's totally safe. It's like it's good to see that big frameworks like Angular also made that move eventually. And I think it's going to be interesting to see because, like I said, I don't think React will change. So if they can solve that performance issue with like the pull re-render, there might be in the future like a way back to like people or frameworks adopting that again, but I don't see that anytime soon.
Thank you.
And even then, like I don't think from a framework level it would change much of like how you use Angular, because you don't need to know that it uses signals, really. Cool. There's no other questions. I'm still going to be around for a little bit, so if you hit me up outside, happy to talk about this. Thank you.